Hey everyone, my name is Thomas, and today I want to talk about something that has taken the Gen AI side by storm, and that is deep agents. And those are what power things like Claude Code or Cursor or Windsurf. And we're going to get a little bit into what those are, but before we start, I just want to level set ourselves with what even is an agent. Like, what is the difference? What's the distinguishing factor between the two? And to be specific, an agent is really nothing more than a tool call, tool result loop. So the human queries an LLM, the LLM looks at its set of tools, tries to determine if any of those are relevant, says, hey system, I want you to perform this tool use, and the system goes and routes to the appropriate tool, hits the thing that it's trying to do, returns some sort of result, and it's augmented into the context for the LLM, and the LLM then responds to the human, and this loop just keeps going and going and going. And sometimes the LLMs need to perform multiple tool calls, whether that's in a parallel fashion and or sequential. And just know that the LLM is just trying to derive the answer by using these external tools. And so to see this really quickly, I just have a pseudo code-ish experience here where we have a top level while loop. We have some sort of array for our message history. The user inputs something, it can be anything. Of course, if the user didn't say anything, we break out of this loop. The first thing we're going to do is translate what the user put inside of this input into a message that's compatible for the large language model. And we invoke with the array of messages, which at this point is just one message from the human, as well as our tools. And let's just assume we already have a toolkit defined here. We would get that response back, and of course we'd want to pin that to our message history as well. And let's just, for the sake of this example, pretend there wasn't a tool use. It would skip straight down to here, display this content from the AI, and loop back. And so now let's pretend there was a tool use. So the latest message that came back from the large language model would have some sort of indication that there's a tool within it. Whether or not you have to iterate through the array of content blocks or you have a defined stop reason that tells you, hey, go look at the tools, either way works. But in this case, we have the Anthropic, or at least Anthropic API inspired style that tells us, hey, there's a particular stop reason. So we're going to iterate through the content of the message because once again, the LLM could actually prompt us to fire off parallel tool calls. We would iterate through those tool uses. We would hit some sort of system-like registry that has all these tools already registered with their appropriate contracts, with their appropriate function signatures, etc. We would then correlate their ID from the initial tool use message to actually create the tool result. And then, of course, we append the tool result message. We invoke the large language model and get a response, and then we append that back. And of course, if there's another tool use, it'll loop back in here, and it just keeps on going, right? Until we hit some sort of answer or until the user breaks out. And this is it, guys. This is the main focus on agents, and this is what they look like. This is about as basic as it gets. And of course, LangChain makes this much, much easier. You don't have to think about maintaining this while loop. You don't have to think about maintaining this registry. You can just do @tool. And in this rudimentary example, we have a getWeather tool and with some sort of doc string. And this is how the LLM would derive the description of the tool. And it just returns something silly. And in this case, we're using the GPT-5 Nano. I gave it the getWeather tool. We send it some sort of message from the human and we get back this response, and then I just pretty printed it. So we can see here, what is the weather in Nashville right from this human message prompt. It did a tool call where it sent in location Nashville, Tennessee. And look at that, I didn't even specify Tennessee. That's the thing about these large language models. They have their own knowledge. They got back, hey, the weather in Nashville, Tennessee is sunny, 72 degrees, because that's as hard coded up here. And then the LLM gave us the output. LangChain also, since it's built on top of LangGraph, I can actually get the graph and print the ASCII version of it. So I just did that to showcase what this simplistic large language model tool use looks like. And just like our chart above, there's a start node, there's a model node, and there's a tool node. And this will repeatedly go back and forth until some sort of end. And you'll notice that this aligns directly with this chart up here. I also want to mention some other things here. There are many libraries out there that do variants of this. There's the Google Agent Development Kit, the Pydantic AI library, OpenAI agents, but just know they're all around creating that nice developer experience where you can register some sort of tool and then have the large language model automatically wired up to it. So that sounds good, but why not stop there? Because it seems like if we can define our own business domain tools, and this thing can just orchestrate it, why do we need to get any more sophisticated? This seems pretty awesome out of the box. You would be correct. It's great at specific niche tasks with 2 to 10 tools, but when you start getting a ton of different turns, a lot of different decisions all at once, that's when things start to flake out. So on the pro side here, I also denoted that it's cheaper and much faster because it doesn't have to do any of this complex planning. It just fires the tool, gets a result, and this is all based on that conversation history. It's also cheaper because it doesn't take as much context. But of course, the cons are what really kill this approach. It very easily will forget tasks because as you keep going through a conversation history, that initial couple messages starts to get a little lost in the sauce. And in addition, it can go down digressions and rabbit holes because if it starts to mess up, then it's going to start going down a certain path and it's hard to recover from that. And in addition, this is most namely due to the fact that memory is short-lived. And this is where we get the term shallow agents. It's really just the message history that powers this agent. And I also just want to call out here that we've talked a lot about agents, but just because you can doesn't mean you absolutely need to. There are other options besides agents. Like you can just run a deterministic workflow if your things don't need an agent. If you know it needs to go from step A to step B to step C with very little conditioning, maybe you should just do that because that will be ultimately much cheaper and you don't have to eval that as much. You can just run standard integration tests or unit tests. And the same thing about prompt chaining as well as LM routing. Even if you need just a simplistic router from a large language model to go to a specific node or two, that's also okay. That's not necessarily considered an agent. But just know these other options exist. Don't feel like you have to force an agent just to be cool. So now we're getting to the reason why you clicked this video, which are deep agents. So I just want to start this off by reading a quote from the promptingguide.ai, which I will link in the description. It states, "We're entering the era of deep agents, systems that strategically plan, remember, and delegate intelligently for solving very complex problems." So that's a very long-winded statement, very generic. So what does that actually mean in practical terms? So I ripped this directly from the LangChain DeepAgent project, which we're going to be going over in this video. But just know that a deep agent is that very same core agent loop, that human to tool use to tool response, back to human, tool use, tool response. Except there are specifically catered tools that aid this process. In particular, there's a planning tool. This thing is supposed to orchestrate all the tasks, maintain some sort of to-do list, and have a general piece for the LLM to follow, or at least a path. Then you have some sort of sub-agent orchestrator as well. So you don't want to cloud your actual context or your precious message history of that deep agent with all of the tool uses and tool results from sub-agent in a very niche specific area. You also have this idea of long-term storage. So not just message history now, but some sort of file system where you can also give access to your deep agent to go and fetch from, like that long-term memory. And then also they wrote system prompt here, but really what this means is context engineering, which is much different than just typical prompt engineering. Like it's a much more methodical process. And so another quote here on this idea of prompting. So once again, from the prompting guide, prompt engineering was and is important, but we will use this new term, context engineering, to emphasize the importance of building context for agents. The instructions need to be explicit, detailed, and intentional to define when to plan, when to use a sub-agent, how to name files, and how to collaborate with humans. Part of context engineering also involves efforts around structured outputs, system prompt optimization, compacting context, evaluating context effectiveness, and optimizing tool definitions. I could not have said anything better than that specific quote, but that is exactly how I would summarize context engineering, is everything they just mentioned there. And so I'll just go ahead and restructure this again. This is recognizing the right moments to pause and strategize rather than immediately executing. You want to have clearly defined tool definitions with practical usage scenarios. You want to have conventions for organizing those files. You want to have well-defined patterns for requesting human-in-the-loop feedback, etc. So after all of that, what I want to talk about is how does this look from a development standpoint? Well, fortunately, LangChain has this thing called DeepAgent. It's a library they released as their attempt to build something that's open source, like a Claude Code. And the example they gave was using internet search. So I hooked it up, gave it an API key, and I ran it. And of course, the question I asked is, what is LangGraph? Something silly. This is actually from their example, and I ran it. And so sure enough, we see this really long-winded response back. You can see the tool calls it did here, and you can even see where it searched through the internet, got that query, got the response, and then wrote something about it. So as you can imagine, this can actually get real world context. You could have done this with shallow agents as well, but this is really to highlight to you how it planned, orchestrated, and did the whole thing. And because this is built on LangGraph, we can still print ASCII, that graph, and you'll see here it's much different than the simplistic create agent. We have some things called middleware before we even get to the model and the tools, and it probably just keeps doing this loop here, also calling that middleware. But what is all of this? What does this mean? So I want to dive a little bit into the code for deep agents. So at the heart of it is this create deep agent. And I just want to highlight before we talk about all this, all they do at the ending of the day is use create agent. And you'll remember from our earlier example, this is exactly what I use for our shallow agents. Right here, this create agent concept under our demo agent. They have taken this exact same concept and applied it for this deep agent. Because like said, the deep agent is still that same agentic loop, just with newer tools on it. And what tools, you may ask? Well, here is the deep agent middleware right out of the gate. You have to-do list. And so let's go explore what to-do list is. And if you don't know about middleware, you can check out my prior video on the LangChain V1 release, but just know there's certain hooks that you can have that do certain things before events are emitted, either to the LLM or before a tool call or before other types of events like before the agent. So if we look here in the to-do list, what does it do? Well, it appends tools dynamically to our LLM. So we don't have to define this idea of how to write to-dos. You may wonder like, well, what does the description look like for this? Well, we can look at the top and get this absolute goldmine of a prompt. This is exactly how the tool will be used. This is exactly how they're going to do to-dos. And there's even task management in here, task states, task completion requirements. And what's really nice about this is that it's not just attached to the deep agent. You can actually use this same to-do middleware just on your shallow agents. It doesn't have to do anything with this deep agent because even look here at the top, it comes from the native LangChain package, not deep agents. So next I want to showcase the file system middleware. I want to emphasize that this is one of the main power sources of a deep agent because of its ability to execute things on a file system. So if we look up here, we see a lot of predefined tool prompts. Read file, edit file, and we even see things like glob. And if you've used Claude Code, you may recognize some of these tool descriptions as even things happening in that experience. But it basically gives the agent the ability to manipulate things, read things, and even use command line tools to get things done. This is huge inside of deep agents. And thankfully, with this file system middleware, the LangChain team has been hard at work defining all of this for us so that we don't have to think about it. They even append the file system tools for us and even wrap the model call and will determine if all of them are applicable to whatever use case depending on the backend you choose. Because it may not be your local system backend, it may be EFS and AWS, or you may want to do something with S3 if you want to go for that style. But regardless, just know that they have your back on this. And they even append the file system prompt as well, because there's going to be some sort of specific system prompt in order to give guidance to that agent. This is part of that context engineering effort. So the next thing I want to talk about is this summarization middleware. This one's pretty straightforward, but just know that before a model is called, after some sort of token limit, they will cut off the messages, preserve some, and then summarize it. And this is to keep the context down for that agent so it can actually focus on its tasks at hand. They also have other things like prompt caching middleware. Of course, if you're not using Anthropic models, they'll just ignore it. But then what's interesting is this patch tool calls middleware. And for those that have ever used Claude Code or used some sort of experience where the chat is just dead and you're trying to type in new things, you press enter, it says blah, 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 cannot complete API call. It may be because of this. So before an agent fires, they're going to ensure and go through all the list of messages that are about to be sent, and they're going to make sure there's not some sort of dangling tool call. And this is very useful in the sense where if something broke and you couldn't complete the response back to the large language model, this will trim off the dead messages effectively. I also glossed over this and was actually in the default middleware of the subagent, but just know the subagent has the very same middlewares that the top level deep agent has. But in the subagent middleware, this is where you could pass in that niche specific shallow subagent, and this can actually do tasks that would delegate to these subagents. And this is how this works through this middleware. And I just want to harp on this one more time, that this is modular. You don't have to use DeepAgent to use these middlewares. It's pretty nice what the LangChain team has done. And then finally, like I mentioned at the bottom, we do the create agent where it does the model, the system prompts, any of the tools we passed in addition to the extended tools from the middleware. It has all the LangGraph isms of checkpointers in the store and the debug mode. etc. The last thing I want to mention here is that the LangChain docs have really good information that break down word for word exactly why these things are valuable and how you could take advantage of them. I was going to make a video about this, but honestly, this documentation covers it. What I wanted this video to be more so about was understanding from a higher level what the difference between a shallow agent and a deep agent are. And so if you found this video useful, please make sure to drop a like and subscribe. Thanks everyone. See you in the next video.